This problem references example 7. So just as a reminder of example 7, we have been given a 3 by 3 matrix, and I'm just going to copy it here. This is straight from the book. 1, 2, 4, 3, 1, 2, 4, 3, 1. And also in example 7, they have given us the inverse. So I'm going to copy that down too because we will be referencing it in this problem. 0.4, negative 0.6, 0.2, 0, 0.4, negative 0.2. Okay, now when we are using matrices and inverse matrices to encrypt and decrypt, what we are going to be doing is going to mimic what you saw in example 7 in the book. We're going to take a phrase, group it into threes, and make 3 by 1 matrices. So, for example, we want to do the message, all is fair in love and war. So I'm going to break this up into threes. All, that's going to become a 3 by 1. I'm going to use that mark just to show a space because we will be needing to use that. All is, so that's a 3-unit matrix. Fair, so we have a space, F-A, I-R space, in, I-N space, love, L-O-V. We'll finish that up, come down to the next line, E space A, N D space, war, W-A-R. This was nice. We had exactly an even multiple of 3 symbols, so it worked out perfectly. If you had an extra, like if it was all's fair in love and wa and didn't have that R, we would just finish up the bottom. We'd add a space in there. But since it works perfectly, we don't have to worry about it here. Okay, next, we're going to fill in number values for all of these letters and spaces. A is 1, B is 2, and so on. Spaces are 27, so I'm just going to come through and put 27s everywhere where there's a space. Okay. Now, let's go through and put our numbers. A is 1. There's multiple ways to do this. I'm just going to go alphabetically, do all of my letters as I come to them. B is 2, C is 3, D is 4, E is 5. I have an E. F, 6, G, 7, H, 8, I, 9. So I've got 2 9s, 3 9s. J is 10, K is 11, L is 12. And I do have 3 L's, so I'll put those 12s in. M is 13, N is 14. I have 2 N's, so I'll put 14s in for those. O is 15. P is 16, Q is 17, R is 18. I've got 2 of those. I realized I just missed a couple letters when I went through. Let me just go back. R is 18. I'll come back to that one, but I missed an F at 6 and a D for 4. Okay, R is 18. S is 19. Got one of those. T is 20. U is 21. V is 22. And W is 23. And that should be all of my letters. I apologize for missing 1 or 2 as I went through before. So I have 9 3 by 1 matrices. And I'm just going to call these, since A is already in use, I'm going to call this matrix B, C, D, E, F, G, H, I, and J. Okay. In order to encrypt this message, what we're going to do is we're going to take matrix A. I went up too high, but I'm just going to copy matrix A again here. Make that black. Remember, matrix A was 1, 2, 4, 3, 1, 2, 4, 3, 1. And I'm going to multiply by each of these in turn. So 9 different matrix multiplications. I'll run through the first 2 manually so we can see how they work, and then I'll just show the remainder of the answers. So let's start with A times B, our first values, 1, 12, 12. when we do our matrix multiplication, we go across the rows in the first matrix, down the columns in the second. Now I only have one column, so my final answer is only going to have one column. So my first row, 1 times 1, 1, plus the second elements, 3 times 12, plus my third elements, 4 times 12 is 48. That's going to give me 85 when I add them all up. Okay, now for my second row, this one I'll do in green. Get second row, again, I only have one column, so it'll be that first column. 2 times 1, plus 1 times 12, plus 3 times 12. And that's going to give me 50. And for my third element, third row, again, same column. 4 times 1, plus 2 times 12, plus 1 times 12. And that's going to give me 40. So my first three numbers in my encrypted message are going to be 85, 50, and 40. Okay. Well, what about my next one? In this case, I will do A times C. That's my second one of those grids. So A doesn't change. And I'm going to multiply this by C, which is 27, 9, and 19. So doing this out, first row times the column. That's going to give me my first element in my answer. So 1 times 27 plus 3 times 9 plus 4 times 19 gives me 130. Second element will be second row times that column. 2 times 27 plus 1 times 9 plus 3 times 19. That gives me 120. And my third element will be the third row, that first column. 4 times 27 plus 2 times 9 plus 1 times 19. That gives me 145. So that is the second piece of my answer. So I'm just going to put a big red box around, since there's a lot of information here. Those are the first two matrices of my answer. Because my message became 9 matrices, I'm going to end up with 9 matrices for my final answer. 1, 2, 3, 4, 5, 6, 7, 8, 9. I already have A times B and C, so this one will be A times D, A times E, F, G, H, I, and J. I'm going to find the elements for these answers just the same way we did for the two that I worked out. So let me show you what these end up being. AD will be 49, 63, 121. AE, 171, 117, and 99. AF, 159, 113, and 91. AG, 145, 105, 100. AH, 90, 40, 75. AI, 134, 113, and 91. And AJ, 98, 101, and 112. So those 9 matrices, 27 numbers in all, is my encoded message. All is fair in love and war. Okay, now what happens if we go the other way? What if I have a message I need to decode? So here is the message that we have received. So let me copy this down. We have 12 numbers that have come in. So we're going to group these in threes. 138, 81, 102. That's my first matrix. 101, 67, 109. My second group of 3. 162, 124, 173. And my fourth grouping is 210, 150, and 165. Okay. Just so we can reference these, I'm going to call this, since I've gone up to J already, let's just skip a little. Let's call this matrix P, Q, R, and S. Now, from example number 7 in the book, we have been given our inverse matrix. As a reminder, I'm going to recopy it just so we don't have to scroll all the way back up. Negative 0.2, 0.2, 0.2. Second row, 0.4, negative 0.6, and 0.2. And then third row is 0, 0.4, negative 0.2. Hey, in order to decode this, I'm going to multiply the inverse times each one of these in turn. Okay, let me do one out again, just to remind you, and then I'll show you the remainders of how we would have done that. Let's take the inverse matrix times P. So I write my inverse matrix. And I'm going to multiply that by P, which is 138, 81, 102. Okay. So let's see what that gives us. That will end up with a 3 by 1 matrix. Matrix multiplication. I'm going to take the first row times the first column. So that first entry will be negative 0.2 times 138 plus the second element in each row and column, which is 0.2 times 81, and the third element, 0.2 times 102. Multiplying all of that out gives me a value of 9. Okay. Likewise, if I take the second row times that column, 0.4 times 138 plus negative 0.6 times 81 plus 0.2 times 102, I end up with a value of 27. Third element in my answer, third row times the column, 0 times 138 plus 0.4 times 81 plus negative 0.2 times 102 gives me an answer of 12. Okay, so I will do this for all of my answers. And what that's going to give me, let me just write out all 4. Here's my first one. This was the inverse times P that we just did. I'm going to multiply the inverse times Q, the inverse times R, and the inverse times S. When I do that, these are the values I'll get. 15, 22, and 5, 27, 25, and 15, 21, 27, 27. Now we just have to decode it. What letters do these stand for? Well, I know, let's put these in red. 27 is my space. So got some spaces, and it looks like my message wasn't quite even, so I finished with a few spaces to make that matrix inflated out to 3 entries. Well, what values are these letters? Well, A, B, C, D, E. E is number 5. Okay, let's see. F, G, H, I. Number 9 is I. J, K, L. 12 is L. Okay. M, N, O. O is 15, and there's 2 of those. My next number is 21. So 15 is O. P, Q, R, S, T, U. 21 is U. 22 is my next letter. That's V. W, X, Y. 25 is Y. So if you look at our message, it says, I love you.